Today's video will demonstrate how to conduct a program trace, even with data that's not quite convenient. Hello, I'm James Helfrich. Recall that a program trace is a method for finding the output of a program by tracing the values of every variable through each line of code. Now, this is easier said than done sometimes when the data is large and complex. This video will demonstrate a technique for solving this problem so the program trace can be really easy to do as well as tell you exactly what you need to know, namely where the bugs are. Recall that a program trace tracks the values of the variables each step of the way. So we're going to start with the C program, and the line numbers are on the left. And we're going to say, okay, there are two variables, year and is leap. At line number 19, the year is 2016. That's our test case. And is leap is not yet defined. At 21, then my year stays unchanged and is leap is 0. At line number 23, my year is unchanged and my is leap is still 0. Now 2016 mod 4 is 0. 0 not equal 0, false. So I do not go to line 24. I now go to line 25. And then at line 25, my year is unchanged and is leap is still 0. Year mod 100 not equal 0. That's 2016 mod 100, which is 16. 16 does not equal 0. Therefore, I'm going to line 26. Now at line 26, year remains unchanged, but now is leap becomes 1. Now because it's an else, if, I'm now going to jump to line 32. And 32, year is unchanged and is leap is unchanged. Observe I do not visit every line of code. I only put in the trace table the lines of code I actually visit. Now, what do we do when we have a large data set? For an example, I want to count all the multiples of a given value in a list of numbers. So here's my pseudocode for count multiples. I have my numbers collection and the number I want to find. I'm going to go through them. Now, the first step, of course, is to number my lines of code. And I'm going to number every single line of code. And then I have my variables, number, find, count, and I. And my numbers is going to be large. There's going to be 7 numbers. And my trace table gets to be really, really, really big. So notice I have to copy the same numbers again and again and again. Notice also that the important information is kind of obscured because I have so much stuff here, which has not really helped me understand the program. So this is kind of a naive way to do the trace. Let's do it a little more informed way. So I'm going to start over again. In this case, I'm only going to put 3 line numbers, A, B, and C. Also, I'm going to have I as my variable that changes, numbers of I. In other words, I'm not going to put the whole numbers array, but just numbers of I. And I'm also going to put the calculation, numbers of I, modulus find. That's not actually a variable, but I can put expressions inside the trace table. And then I'll have count the number I care about. Now notice how numbers and find is not in there, so I'm just going to write them once. And here are the same numbers I had before in my last example. So in line A, I is 0. Numbers of I is 3, looking up in the numbers array. Numbers of I modulus find is 3, mod find is 3, 0. And then my count is 0, because I have not changed it yet. Then I'll go into line B because it turns out 0 is, my if statement is true, and now increment count by 1. Now I'll go back to A, and now I is 1, and numbers of I is now 6, and numbers of I mod find is again 0. So now I'll go from A into B. Now I'll go back to A again, and now I is 2, numbers of I is 2, 2 mod 3 is 2, and so therefore I'm not going to go into B, but I'll go back to A. So in this case, I is 3, numbers of I is negative 6. Negative 6 mod find is 3 is going to be 0. And so now I'm going to go into B and increment count by 1. Next, an index 4, numbers of I is 5. So I'm not going to go into my if statement. And then numbers of I is 1. I'm not going to go into the if statement. And then my last one, numbers of I is 3. 3 mod 3 is 0. Therefore, I'm going to go from A into B. And when I'm finished here, then I'm going to go to line C. Now I is undefined, numbers of I is undefined, numbers of I mod find is undefined, but I only count about value 4. Now observe that this trace table highlights the things I care about. When does count change? It also helps me compute the values because I have an expression in the column. And finally, there's no redundant information. This is a far better way to do a program trace. You can learn more about conducting a program trace by taking a look at section step 2, number the lines, in the trace chapter of the software design textbook.